For the last section in this Unit 9, we are going to look at 11.4, which is going to be area and perimeter of composite figures. Composite figures are just figures made up of more than one polygon. So for our first example, we're going to find the area of the shaded region. When I look at this picture that's provided here, in order to find the area of just the shaded part, I'm going to be looking at taking the area of the bigger rectangle and then subtracting away the area of the smaller rectangle. That way it just gives me the shaded part. So let's start by looking at the bigger rectangle. So area of a rectangle is length times width. Okay, so when I look at the total length of this bigger rectangle, I of course have this length of 100 and then this length of 25, and then what would be this length of 25 over here, giving me a total length of 150 feet. When I look at the width, I have this width of 20 in addition to this 25 and this 25, giving me a total length of 70 feet. So now I'm going to substitute in length of 150 feet, width of 70 feet. 150 times 70 is going to give me a total area of 10,500 square feet for the larger rectangle. Now let's look at the smaller rectangle. Area is length times width again. This time it's easy to see that the length is 100 and the width is 20 of this smaller rectangle found on the inside. This is the one I'm talking about. Okay, 100 times 20 is giving me an overall area of 2,000 square feet for that smaller rectangle. Now I'm going to subtract the areas to get the shaded region. So 10,500 minus 2,000 gives me an overall area for the shaded region of 8,500 square feet. Okay? Let's look at another one. When I look at this figure, I see a few different polygons. Again, I'm going to find the area. So we're going to be looking at the area of a few. So the first one I see is this rectangle. So we'll have an area of a rectangle in addition to an area of a triangle is another figure that I see, another polygon. In addition to two semicircles. So I have a semicircle here and a semicircle here, and two semicircles is going to give me just one full circle. So the area of a circle. Okay? So area of a rectangle, length times width. The length of the circle is 32. The width of a circle is 16. So 32 times 16 is going to give me an area of that rectangle of 512 square feet. Area of a triangle, 1/2 base times height. So 1/2, the base of the triangle is the same as the width of the the length of the rectangle, 32. And the height of the triangle is 15. This would be like its height there. And 1/2 times 32 times 15, 240 square feet. Area of a circle, pi r squared. So this 16 is symbolizing the entire diameter of the circle, meaning that the radius is half of it, which is 8. So pi 8 squared, which is 64 pi, which is approximately 201.1 square feet rounded. So now I'm going to add up all those areas together. 512 plus 240 plus 201.1 gives me a total area of this composite figure of 953.1 square feet. Okay? Moving on. When I look at this figure, I see one trapezoid, another trapezoid, which is the same. So two identical trapezoids with the same height and the same bases there. And then from these trapezoids, we are going to take away or subtract two semicircles, which is going to be one whole circle. So I have the area of a trapezoid, and really I'm just going to multiply it by 2 because they're two identical ones. And then I'm going to subtract away that area of that circle. Okay, so area of a trapezoid is 1/2 height base plus base. So that's going to be 1/2. The height is 7 because that's what's the perpendicular part there shown. And each base, those are the parallel parts, 8 plus 16. And one area, or the area of one trapezoid, is going to be 84 square units. And so if I multiply that by 2, I get that both the trapezoids together have an area of 168 square units. Now let's look at the area of my circle. So area is pi r squared. 8 again is representing the diameter, so the radius is going to be 4. So that's pi 4 squared, which is 16 pi. Rounded to the nearest tenth, 16 pi is the same as 50.3 square units. And now I'm just going to subtract that. So 168 minus 50.3 gives me an overall area of 117.7 square units. Again, when there's no unit listed in your picture, such as centimeters, inches, meters, whatever, you're just going to put that word units, so that way you can still represent it as square units for area. Okay? And last one, we are going to be finding the area and the perimeter of the following figure. So I'm going to start with the area first. When I look at this picture, I see this rectangle again. So we're going to start by taking this area of that rectangle, and then I see a triangle over here and what would be another identical triangle over here. That would still be 5, and we'll talk about what their base measures are going to be here in a second. So I'm going to have 2 and then area of these triangles again. So they're going to be identical triangles. Okay? So area of a rectangle, length times width. The length of the rectangle is what you're seeing here at the bottom. That's 9, and the width of the rectangle is 5. And so area of this rectangle is 45 square inches. And area of a triangle is 1/2 base times height. 1/2. So we need to talk about this base. So if this total length is 22, okay, and I take 22 and I subtract away what I know this part to be, which is 9. So if I take 22 and I subtract away 9, I get an overlap of 13. So between this area and this area, I need to have 13 total inches. So I'm going to divide that 13 by 2, and I get that both of these triangles then is going to have a base, or they're going to have a base of 6.5 inches. Okay, so 1/2, the base we just found was 6.5 inches, and the height is 5 inches. So one area of, or the area of one triangle is going to be 16.25 square inches. And then I'm going to go ahead and multiply that by 2, since they're two identical triangles. to get a total area of 32.5 for both of those triangles. Okay, so now I'm going to add that 45 for the rectangle, 32.5 for both triangles, and I get a total area of 77.5 square inches. Okay, that is the area part. Okay, I'm going to erase this slide then, and we're going to start over looking at the perimeter part. Okay, so now let's look at the perimeter. For the perimeter of a composite figure, we're just going to add the sides as we go around. So like, let's just say that I make my starting point here. So for my perimeter, I'm going to go ahead and start by adding 22. As I keep going around, I need to know this distance. That way I can add it. Well, this was my triangle. We just found that this is 6.5. This is 5. This is a right triangle. I'm going to use Pythagorean theorem. Okay, and I'm just going to talk through this for you guys. So I would do 5 squared plus 6.5 squared. When I do that, I get 67.25, and then, let me write that down, 67.25. To help us just add this together with our perimeter, we'll go ahead and take that square root instead of simplifying it. It already has a decimal in it anyway. So let's take that square root, round it to the nearest tenth to help us. That's going to give us a hypotenuse measure of approximately 8.2, and that's what's going to help me then with my perimeter. So that's 8.2. This side, when we get over there, that's going to be the same 8.2, and we'll add that. So let's keep going. So I got my 22, I got my 8.2, need to add in my 9, and then I need to add 8.2 again. Okay, so 4 total sides that I'm looking at, 22, 8.2, 9, plus another 8.2, gives me a total perimeter for this area of 47.4, and when we're looking at perimeter, just inches. So 47.4 inches is the total perimeter of this composite figure.